I'm Ava.
And I'm Beth.
This is Calculus AB.
Are you ready to graph this function? I am. Today we're doing secant and tangent lines.
Tangent lines have an instantaneous rate of change, while secant lines have an average rate of change. This is a very important distinction to remember in calculus.
This problem, we're finding the average rate of change for the closed interval 0, 8. y1 minus y divided by x1 minus x equals 191 minus -1 divided by 8 minus 0, which simplifies to 191 plus 1 divided by 8. This simplifies to 24.
This is a graph of negative x squared, and they're asking you to find the average rate of change on the interval from -2 to 1. What I'm doing here is locating the 2 points and connecting them with a line, which is called a secant line. Just like we did in the table example, we're basically taking those 2 points and finding the slope. So the 2 points are -2, 4 and 1, -1, and then we can use the y1 minus y over x1 minus x equation, and we plug those points in, and the slope simplifies to 1.
Now we're going to be looking at tangent lines. This is our table example. We're going to estimate the instantaneous rate of change at x equals 3 using the table values for x equals 3 and x equals 4.
Just to clarify, the difference between instantaneous and average rate of change is this. The average rate of change is over an interval of time, whereas the instantaneous rate of change occurs at one point.
So we're using y1 minus y over x1 minus x. So that gives us 81 minus 27 divided by 4 minus 3, giving us the final answer of 54. This is an estimation, and given this information, this is as close to exact as possible. Here we graph the equation y equals x minus 2 squared plus 1. We're estimating the slope of the tangent line at x equals 3. A tangent line only touches a graph at one point.
Since we're finding the instantaneous rate of change in this case, which is the same as the slope of the tangent line, we're going to draw in a sort of guesstimation of the tangent line at x equals 3. So I drew this line here, and then you need to sort of guess another point that's on that line. And so as you can see, it kind of looks like 2, 0 is also on the line I drew. So then we can use the points 2, 0 and 3, 2 and plug that into a y1 minus y over x1 minus x equation. The estimated slope we got was 2. Once again, this is an estimation for instantaneous rate of change. It might not be the exact rate of change here because we're kind of guessing, but we will get into exact rates of change later on in the show.
Here on our CAS calculator, we're not endorsing CAS in any way, shape, or form, or sponsored by CAS. We just happen to use this calculator because that's what we think is a good calculator. We have the graph of y equals -x squared. So we have 2 points, -2, -4, which we're going to refer to as point x, and point 1, -1, which we're going to refer to as y. As the point x approaches point y, the secant line gets closer and closer to becoming a tangent line. When the points x and y overlap, it becomes a tangent line. Thank you for watching this video. Please feel free to subscribe, drop a like, In the description below, we have our email, and feel free to email us questions, comments, feedback,